Let's go to LeetCode 2642, design graph with shortest path calculator. For this question, to give us, let's to design a directly weighted graph that consists of n nodes. And at the beginning, it has an edges array, and it lets us to implement the add edge function, and also it let us try to calculate the node 1 and node 2's shortest distance. So for this question, if we know something like the Bellman-Ford algorithm, there is a dynamic programming approach. We can just use that kind of approach to do this question very easily. That for that approach is that for every edge, right? For example, there is n nodes. We create a distance array, and at the beginning we set that as infinity, and we're trying to add edges one by one. And for the edge, we are trying to see iterate, for example, some other nodes, right? For example, from A to B, if we have edge, for example, C and E, right? If Z goes to C and goes to E, it's possible that they will update that as long as if the CE distance get decreased, it's possible that AB distance get decreased. So what we do is that we iterate from 1 to n, right? And trying to see if 1 to edge 0 plus edge 0, this kind of weight, and plus the edge 1 to B. This is also 1 to n, right? Trying to see if the distance decrease. If we have this distance decrease, then we update the distance array. For shortest path, we just check the distance array in one time. So but the at edge, right? We need to have the edge iterate these edges, right? Iterate the vertex, right? Vertex and the vertices. So this will be V square, and we also check the distance, trying to see whether it decreased, right? So so this kind of at edges, if there are E number of edges, so the operations will be EV square, right? So this is if we know the Bellman-Ford dynamic approach, dynamic program approach, we can do this very quick. It should be very easy to solve. So let's begin to write code for this. We are going to create, for example, let's set this in, right? So we'll have this dot n equals n. We're going to have a distance array, right? Distance array in the distance array. That's that distance equals new distance n, right? And we are going to have, for example, we have a private final static limit if equals integer dot max. So we're going to have for int d distance. We'll have arrays d if, and also we'll set every point which itself is 0, right? For the int I equals 0, I smaller than n, I plus plus we have distance I equals 0, right? At the beginning, right? So there are edges. Actually, we can implement these edges, right? So we have the add edge functions, so we can call this, right? So so we can do this for every edge in edge. This is the add edge. Okay. So for this kind of function, how to about the add age, right? So what we do is that we'll find the distance. If distance age is 0, age 1 is smaller, equal to age 2, right? That means at this age that will not make any difference. We just return. Otherwise, we'll have distance age 0, age 1 equals age 2, right? And what we do is that we are going to iterate for int I equals 0, I smaller than n, I plus plus, and for int j equals 0, j is smaller than n, j plus plus. And we'll say if I equals j, we'll continue, right? And then we'll say distance I j equals mass dot mean distance I j, and distance I h 0, right? And then we add the this h2, right? ch2, because this is we have another path, and also add distance h1 to j, right? h1 j. So that's it. And in the we just return distance node 1, node 2, right? Final static. Thirty. New int. So actually, the things that we should not just return, because it is not sometimes it's not reachable. So if it is INF, right? So it will be -1. Otherwise, will be this distance, right? Okay.